Okay, good day again. I don't know. Wala na ako na screen share ang previous recording. So again, I will repeat my discussion on the uh, pipe series parallel and network configuration and pipe flow analysis. So we will discuss pipes in series, parallel, and pipe networks. Okay, so again, I will discuss. Pasensya. Man ako na-share screen. Okay, so we will start our discussion in series, pipes in series. So when there are two or more pipes of different diameter, actually different pipes, different diameter, different roughness coefficient, different material. So if they are connected in series with each other, so a series means gisumpay-sumpay from end to end. Let's say from a certain point, then sumpayan. Two or more pipes. It can be two or three or four and so on. So daghan nga pipes. So if they're connected in series, connected with each other. So if they're in series, so mao lang ni siya ang timan-an. Um, the only difference between series and parallel actually is in terms of their discharges, Q, and head loss. So mao na siya ang duha ka the two relationship between series and parallel. So for series, unahon na to ang Q. For series, um, it's a pipe A, pipe A and pipe B. So since they are connected in series connection, so the Q passing through pipe A is equal to the Q passing in pipe B. So kung how much ang discharge, ang volume per cubic per unit time ang mi sulod sa A is equal na sa miagi sa B. So sumpay raman sila. So kung pila ni sulod sa A, mao sa lang ni sulod sa B. Okay? So it means that their Q are equal. So Q at pipe of pipe A is equal to Q of pipe B. Now, arita sa head loss. So since they are in series, sumpay sila. So we can say that the head loss, let's say at point 1, let's say mo ni ang atong point 1, ang tank on the left. Then we have point 2, tank on the right. So when we say ang head loss or total head loss from point 1 to point 2 um, is equal to the summation or sum of head loss of pipe A and pipe B. Okay, so balik ko na ko. Ang ilang Q are the same QA, QB. But ang Q, abet ang head loss sa QA is not necessarily equal. We don't know actually. We don't know if it's equal or not equal ang head loss sa pipe A and pipe B. But what we do know is that ang iyang head loss is if i-sum up na to ang iyang duha ka head loss at pipe A, head loss at pipe B is that is equal to the head loss of point 1 and point 2. Okay? Balik ko na ko, ang iyang Q is equal, ang iyang head loss is daily equal for series pipes. For, mani akong gi-discuss ganina. Mathematically, we can express that the Q1 is equal to Q2 or QA is equal to QB. But ang iyang head loss is sum of all the head loss between Q1 and Q2. I mean, point 1 and point 2 total. Not necessarily the same ang head loss, but i-add mo silang duha, that's equal to the head loss of total from point 1 to point 2. Okay. So, mauna siya for series. For parallel, bali na sad siya. For parallel, the head loss are now the same. Let's say if we have pipe A and pipe B. So, natay pipe A and pipe B, natay QA and QB. So, ang head loss sa pipe A and pipe B, they are the same. Equal sila head loss, but ang ilang Q are not actually the same. We don't know kung same ba or dili. Wata kabaloan na, sulbon pa na siya. But ang kabauta is, ang Q nila, kung atong i-add, QA plus QB is equal to Q1 and Q2. So kung pilay Q, kung isulod at this point here, is equal sa Q nga nigawas, then equal sa QA plus QB. Okay. Opposite sila ha. For series, equal sila og Q. For parallel, dili equal ilang Q. For series, dili equal ang ilang head loss. For parallel, equal ang ilang head loss. Okay, that's the difference between the two. Yeah, mathematically, it can be expressed in this manner. Okay. For pipe network, actually, pipe network, it's more than series and parallel kay network naman siya. So in most cases, water distribution consists of complex interconnected pipes that serves reservoirs or pumps. It delivers water from the treatment plants to the consumer. And water demand is highly variable. So maglahi-lahi mo na ang water demand. Sometimes mo kusog diri nga part, sometimes mo hinay diri nga part. So it's very variable. So whereas supply is normally constant. So thus the distribution system must include storage element and must be capable of flexible operation. So pipe network analysis involves the determination of the pipe flow rates and pressure heads of the outflows points of the network. So the rate of flow and pressure heads must satisfy the continuity and energy equations. So it must satisfy to the continuity and energy equations. So it must Bernoulli's energy equation and continuity equation can still be applied. So those things that we discussed earlier. So the earliest systematic method of network analysis is called the Hardy-Cross method. It is known as the head balance or closed loop method. This method is applicable to system in which pipes form closed loops. So closed loops meaning kung unsay ni gawas mao ang ni sulod, so walay leakage in between. Assuming wala leakage in between. So the outflows from the system are generally assumed to occur at the nodes junction. So mani siya ang usa sa mga earliest and rudimentary form of network analysis, the Hardy-Cross. We're assuming that the inflow and outflow occurs at the junction sa connection sa eskina. So for a given pipe system with known outflows, the Hardy-Cross method is an iterative function based on initially iterated flows in the pipe. So iteration, it means nga na siya series of iteration, pwede siya iteration 1, iteration 2, or trial 1, trial 2. So I don't know if you're familiar with iteration, gidiscuss siguro ni sa inyong numerical methods, di ba? So at a junction, this flow must satisfy the continuity criterion. The algebraic sum of the flow rates and the pipe meeting at the junction together with any external flow is 0. So ang iyang algebraic sum, meaning kung unsay ni sulod, unsay plus, mausad ang equal sa nigawas ang minus. So equal na dapat sa 0. Walay mahibilin. So mao ni siya ang process. Assigning clockwise flows under associated head losses are positive. The procedure is as follows. So assume values of Q to satisfy summation of Q is equal to 0. Summation of Q, the algebraic summation, how much ang input must be equal to the amount of output. Pilang ni sulod equal sa nigawas, a total. So calculate head loss from Q using K is equal to Q2. So instead of applying the entire equation of head loss, so magbutang lang ta og certain correction factor, not correction factor, coefficient, head loss coefficient nga K. So head loss is equal to K times Q. Okay. So the summation of head loss must be equal to 0. Summation must be the algebraic summation. Then the solution is correct kung 0. Kung dili siya 0, at first attempt, mag-apply ta og correction factor delta Q atong punan or kuhaan ang Q atong i-adjust ginagmay-gagmay ang Q to repeat in step 2. So manang naatay iteration. So if the head loss is not equal to 0 or the algebraic sum of head loss is not equal to 0, we must apply a correction factor delta Q. So atong punan ginagmay o kuhaan. So to determine pila ang mapuno, pila ang makuha sa atong initial assignment sa atong Q, we can just follow this equation. Sum of the head loss over twice the sum of the head loss over Q, then it's negative. Okay, so for practical purposes, dili na nato paabton jud og 0 ang iyang total head loss. So if the head loss is kuan lang siya, less than 0.01 of a meter, or ang iyang delta Q is less than 1 liters per second. So okay na siya. Because if abton dyan nato na og 0, it can be more tedious, mas taas siya og trial, then dili na sad siya practical. Okay? For practical purposes, for practical reasons, di naman jud kailangan nga exactly ang iyang value sa summation of head loss. Okay? So kuan mo gana siya, magka-taas and convergence mo gana siya. So familiar siguro mo in your numerical methods. So mo converge na siya, pero dugay pa na siya mo converge kay napa na siya gagmay nga decimal. Okay, so we have an example. So we have a pipe of diameter equal to 6 centimeter and has a length of 1,000 meter with friction coefficient factor equal to 0.018. Is connected in parallel between the 2 points. So nakay 2 points M and N with another pipe. So another pipe niya is 8 centimeter in diameter. Then it has a length of 800 meters and having a friction coefficient factor equal to 0.02. So the total discharge of the system is 20 liters per second. So ang nisulod 20 liters per second, it must be equal sa mugawas nga 20 liters per second also. Ang ato lang need to determine is to find or to solve the discharge in each of the pipe. So mao ni ang, let's say, point M, mao ni ang point N, and this is the pipe 1, this is the pipe 2. Q, ang nisulod is 20 liters per second. Ang nigawas is 20 liters per second. So we must need to determine Q1 and Q2. Okay. So first, since the connection is in parallel, so we know kung parallel, Q is equal to Q1 plus Q2. Wala ta kabalo sa Q1 and Q2, pero kabalo ta pila Q, which is 0.02. So we can express that relationship, that is equal to pi over the area. This is the area, pi over 4 d squared. Actually, this is not square. V1 lang ni siya. V1 area. This is the area times velocity. This is the velocity. Dili ni siya square, ha? this is not square. V1 and V2 na siya. Then for 5.2, the area and the velocity. We don't know the velocity. Wa man ta kabalo sa Q. So we just leave it as that. The relationship between V1 and V2. So duha makabuk atong unknown. Then we must formulate another equation. So another equation is the relationship between its head loss. We know that for parallel pipes, we know that their head loss are equal. So we can just equate head loss at point 1. No. Head loss at pipe 1, then head loss at pipe 2. Okay, so in this case, we can just cancel 2G. Same naman siya 2D. So substitute friction factor, length, and velocity. Friction factor, length, velocity, diameter 1, diameter at pipe 2. We do not know the V1 and V2, but in this equation, we can establish a connection or the relationship between B1 and B2. Now, in this case, we can substitute D1. Kini siya nga kini siya. We can substitute this one in equation 1. Diri ilisa na to ni V2. So, the only unknown in this equation is V2. So, we can solve for V2 as 2.73 meters per second. So, once we can solve for V2, we can now solve for V1. Okay? So, nanatay V1. Or, based on this equation, area times velocity, we can solve for Q2. So, likewise, we can solve for Q1. So, we can check our answer. We can add Q1 plus Q2. It must equal to Q, mga 0.02, 20 liters per second. So, in that way, sakto atong answer. Sakto ang answer sa example. Okay, example for pipe network. So we have a square, 4 pipes connected with each other. It forms a square. The pipes are all 1 kilometer long and 300 mm in diameter with a friction factor of 0.013. So based on that, naatay correction factor nga 0.013, then naatay length, then naatay diameter. We can now solve for the head loss if we know the Q. If we know the velocity, di ba? So, wala man takabalo sa velocity. Wala takabalo sa velocity. May atong goal is to determine the discharge. What we know is nalantay input diri nga 100 liters. Natay ni sulod nga 100 liters. Diri nga point natay ni gawas nga 40. Natay ni gawas nga 40. Then at this junction natay ni gawas, natay outlet nga 20. So 40 plus 40 plus 20, it must equal to 100. So it's a closed loop. So it is equal. Some algebraic summation of Q are equal. So, okay, satisfy the continuous equation of the nodes. So, calculate the head loss, HL, K1, and Q2. So, actually, solve man nato ni K because na given ang length, the diameter, and the friction coefficient. Okay. Head loss must be equal to major loss plus minor loss, but it's stated in the problem that minor loss can be neglected. Okay, so the only thing nga losses na to is this equation, friction factor, length over diameter, V squared over 2G. So in that way, we can solve K1 or head loss in terms of Q. So we can just we can use this one, friction factor times length over diameter. So V squared over 2G. So V squared. So QA. So naatay value nga 554 na Q2. 554 Q2, that's the head loss. So, ang atong K is 554. Mamana siya. Atong K. So, atong i-tabulate pipe AB, BC, CD, and AD. AB, BC, CD, and AD. So actually, kining mga values are just assumptions. So atong gi-assume nga ang AB 60. Then ang BC 40. Ang BC 40. Then ang AD pila may AD lang assumption 40. So CD assumption ni siya nga 0, walay ni gawas. Assumption ni nga walay ni gawas because walay ni flow between CD because 40 liters mo nang iyang ni gawas diri. Then diri sad is 40 liters. So marag wala siguro ni gawas. Marag walay ni flow between DC. Well, that's the anyway we can prove that later. Mo na assumption at first. 0. Natay head loss. If we will use this one kining 60. Kung atong Q 60, atong assume nga Q 60, 60 liters per second, makakuha tag head loss nga 2 based on this K 554. So on 0.866, 0 of course, then negative 0.866. And then na naman tay HL, na naman tay Q, we can solve for HL nga 0.033 and that one. And then we need to sum up all the head loss. Sum up na to ni tanan. So if it is more than 0.01 meter, then di pa pwede ato pang butangan o correction. So na po tayo another iteration, another trial, and so on. So line na trial. So it's more than 0.01, 2 man siya. So next trial, before ta mag-trial, ato sang i-determine kung pila may atong increment, pila may how much ang atong i-add sa atong Q, di ba? First assumption sa atong Q, di man to tinuod. So atong i-adjust ang Q. So to determine kung pila adjustment sa atong Q, we need to follow this equation. Summation of HL over twice the summation of HL. That's algebraic summation over Q. Actually, that's negative na siya. That's part of the equation. Then based on that equation, natin na-solve nga 12.92. That's negative 0.92. So atong i-add. So 60 plus negative 12.92, 40 plus negative 12.92, then negative 12.92, then negative 40 plus negative 12.92. So based on that Q, makakuha ta og head loss. Okay? Natay head loss. Then napo tay HL over Q. And if we sum up our head loss, siya nga 0.0107. Actually, it's more than 0.01 kay na 0.07, but ingon siya okay na lang daw. That's approximately. Pero pwede ba dyan siya kung magbutang tawag another trial, like third trial, ma-change na po ning value sa Q. Pero actually gamay na lang na siya og changes later on. Gamay na lang na sila og difference. So ari na lang daw kutob, okay na lang kuno ni 0.01 meter. Approximately 0.01 meter. So in that way ang discharge niya, that's 47, 27, 13. Yan na lang gi-run off, then 53. Yan na lang gi-run off ang discharge. Okay? So I think that would be all for our discussion. Hopefully na-share screen na dyan siya. So thank you for your attention. So that would be all for this discussion.